Hi all, this is a quick overview of HawkEye flood level detection system. Here we are using traffic cameras, CCTVs, security cameras or any cameras, even handheld cameras compared to satellite or radars. This gives us an advantage wherein we are able to get continuous feed from the traffic cameras or the ATMs or any other cameras that are willing to provide us the information. In addition to that, wherever places are far, people and there are no installed cameras, people can still send us information from their mobile cameras. This would be stored on a cloud. Let's go technically one by one. So here we see the Watson visual recognition system, which has been trained with around 15 to 16 models. Each model is able to identify different vehicles in different situations. So here we can see a four-wheeler light vehicle in flood situation till the tire level. Here similarly the four-wheeler flood vehicle. Here we can see people till ankle deep, and so on. So here we can see a heavy vehicle till flood, and we here we see a light flood. Here we see two-wheeler in flood as well as a light vehicle in flood. Here we see majority of two-wheeler in flood as well as light vehicles in flood. Similarly, here we can see heavy four-wheelers in flood and so on. So here we see another two-wheeler in flood. So based on this, it can identify different classes of people, and using Python we are able to get the relevant information. So once we get the relevant information, we are able to store this information in a cloud. So once the information is stored in the cloud, it is stored in different CSV files, and we are able to get the information from each CSV file. So here a quick walkthrough. So basically we want to store the information of all the subscribers. We categorize them into authority or public, and once we categorize them into authority or public, we further categorize them into authority level. So based on the levels of village, city, district, state or nation, we have different numbers, and if it is for general public, it is a different number. Similarly, we have option to enroll as well. So if someone wants exclusive email access only, or he wants SMS, WhatsApp, or combinations of anything, he is able to enroll to them. So in the subscriber file, he has the enroll type. Enroll basically is a true or false, where he can turn it off at a given time. So we have the latitude and longitude of the subscriber as well, so that based on the range we are able to give. For a normal subscriber, we generally give 5, which could be a 5-kilometer range, and for government authority we give 10 kilometers to 20, 30 and 40, different depending on the range. We have the mobile number, WhatsApp number and email ID, along with the name and other stuff that can help us work with the models. So these are stored on the cloud, and we are able to extract them with the help of IBM Watson Studio uh, Jupyter file. So first of all, we start off with the installation of the SQL. Then we get the data. Once we get the data, we we use the data to pull out the email ID. Here we can see the mobile number, WhatsApp, and the email ID. First we are going to trigger the email ID. Here we are able to get the information, and using Gmail we are able to send out an email. Later on, if the subscriber has subscribed for SMS or WhatsApp as well, we are able to use Twilio to send out SMS. Once once a WhatsApp and SMS is sent, the process ends. So other than the SMS system, we have the Watson assistant as well, which is able to help users who are not subscribed to get information, or to get information for a location they are not subscribed for. Here we are able to see that if someone is giving high flood level in Kolkata, then he is getting a different navigation. Whereas if he is giving location which is not yet configured. So let's clear this out and have a quick demo once again. So so once he gives information, he is able to get this information. This is basically a file on the local system right now. Let's open it. So this is the uh, navigation. Okay, here we are showing different levels of flood using circles. So red being more dangerous and green being okay. Blue is navigatable. That is how we have decided. Here on Facebook, we are able to get this same information. So let's say we type Hyderabad flood. So Watson takes a bit of time, but returns as a location. Let's try Mumbai rain, and we got the information of Hyderabad. We need a bit of training. Here we had a typo, so it gave us wrong information, but when we gave the proper information, it gave us the information. So let's go ahead and give a sample information. So based on the location, so if a location is not identified, or if a calamity is not tagged, so let's say we have earthquake. Let's write here earthquake. So Uh, we have some issues due to my recent training, but basically we are able to get the required information. And once we say, I'm having some issues, but as we see, if a particular location is not identified, we are given the map, Google map, wherein we can see the actual level of floods in different areas. Here in Muzaffarpur, there was a abnormal flood situation. So this is how Google Map shows. But this is what we are trying to achieve on our on our mapping system as well. Right now this is local, but we want to make this live. Thank you.